This video is part of an algebra course created by Great IT Courses. You can subscribe to the complete course free of cost on udemy.com. You can find the relevant information and links in the description below. Thank you. So in this video we want to talk about factoring a trinomial with leading coefficient, with a leading coefficient of 1, of course. Let me give you an example of what I mean by that, a leading coefficient of 1. For example, you have a trinomial like x squared plus 5x plus 6. So x squared plus 5x plus 6. As we discussed before, in this trinomial, this is the leading term because it has the greatest power of the variable in the whole trinomial. And so now what is the coefficient of this leading term? It's basically 1 into x squared. The coefficient of this term is 5. The coefficient of this term is basically 6. But this is, as you know, constant. So, but now here, as you see, the leading coefficient of the leading coefficient in this trinomial is 1. So this is an example of a trinomial with the leading coefficient of 1. Now I want to factorize this trinomial. As we discussed before, we've been basically working with trinomials and how to basically use the GFC, which was GCF. We're working with greatest common factor to factorize polynomials in general. Now, the greatest common factor was a basically great way to factorize polynomials, but the problem here is that when you look at this polynomial, this term in the polynomial has x squared, 5x and 6. So there is no common factor in any of these terms except for 1. So the greatest common factor in this polynomial in all of the terms is 1. And so if I were to use the GCF way, then I would simply write this as 1 into x squared plus 5x plus 6, and then I would still end up with the same polynomial I started with in the first place. So that's not basically that's not what I wanted, and that's not the way to go. So basically what you want to do, we want to find another way to factorize this polynomial. Now let's just for a moment assume that we know how to solve this kind of problem. So let me rewrite this x squared plus 5x plus 6. Now, let me rewrite this equation as, or this polynomial as x squared plus 2 plus 3 into x plus 2 into 3. So 2 into 3 is equal to 6. 2 plus 3 is equal to 5. And here's my x and here's my x squared. So basically I have not changed anything here. I've just written the polynomial. It's just in a slightly different way, but basically the same value. Now let's distribute this x into this parentheses, or this pair of parentheses. So that would be x squared plus 2x plus 3x plus 2 into 3. Now you can see that there are a few things that now you can do. You're basically having the same polynomial but written in a slightly different way. And now, for instance, what I can do is I can group x squared plus 2x together I can do this, and I can group these two terms together. So I can write 3x plus 2 into 3. I can group these two together. And so now you can see that the greatest common factor between these two terms is x. So I can write this as x into x plus 2. Now the greatest common factor between these two terms is 3. So I can write this as 3 into x plus 2. And now I have two terms over here. Basically, this could be one of the terms that I have, and this is basically another term joined with an addition sign. So what I can do now is basically I could now try to find another greatest common factor between these two terms, and that would be x plus 2. It's already there standing in front of you. So x plus 2, I can take an x plus 2 out. I can write this as x plus 2 into, now this whole term divided by x plus 2 is equal to x plus this whole term divided by x plus 2 is equal to 3, so x plus 3. So that basically means that, so this whole thing that we've done over here, and it was a great way to factorize this polynomial or trinomial, that basically means that x squared plus 5x plus 6 is equal to x plus 2 into x plus 3. And these are the two, basically the two factors representing this trinomial. And so that brings us to the factoring a trinomial with leading coefficient 1 rule. And let me now tell you the whole thing in a general way so that you can learn and apply this to other problems that you might have. So basically what I did here, I had a trinomial like x squared plus 5x plus 6. And so what I did was I wrote this term as a sum of two terms. So let's now try to build a model on the right based on what I did, based on what we did over here. I write this term over here, this term as a sum of two terms. So I wrote this as x squared. I didn't touch that. And then I wrote x5 as 2 plus 3. And then I wrote this term as a product of two terms. So 2 into 3. So now let's build a model over here. So now let me write a general, I can write a general representation of this trinomial over here, and that would be x squared. Let me write this as bx plus c. This is capital C and this is capital B. And so what I did here was that I didn't do anything to x, so x squared is there as it was, and I wrote b as, and as you can see here, the two terms that I used here are 2 plus 2 and plus 3, and again here I'm using the same two terms, 2 and plus 2 and plus 3, so I can just give them basically two common names here. I can call them, for example, a and b. So I can write this as, based on this, so b was equal to here 5, 2 plus 3, or a plus b into x, and C was equal to A into B. And that's what we did in this step. Next, I multiplied x into this, the two terms in this pair of parentheses. So I can write this as x squared plus 2x plus 3x plus 2 into 3. So here I can do the same thing. I can write this as x squared plus ax plus bx plus a into b. And then I tried grouping two. I tried to group basically, for example, these two terms together, because I thought I could find the greatest common factor of x between these two. And then I grouped these two together because I thought I could find the greatest common factor of 3 between these two. So I wrote this as x squared plus 2x and grouped together plus 3x plus 2 into 3, and then I group these two together. So here I can do the same thing. Here I can find the greatest common factor of x between these two. So I can write this as x squared plus ax and group them together, and plus bx plus a into b, and group these two together. And now here what I did was just factor out the greatest common factor that in these two terms and in these two terms as well. So basically here I can write x into x plus 2 plus 3 into x plus 2. And so I can do the same thing over here. I can here write x plus a plus b into x plus a. So now I have two terms over here, x into x plus 2 and 3 into x plus 2. And the greatest common factor here, as you see, is x plus 2. So I can take an x plus 2 out. I can write this as x plus 2 into x plus 3, as we did before. So here again I can write x plus a into x plus b, and that is the simplified version of your trinomial. So that basically means that x squared plus bx plus c is equal to x plus a into x plus b, where b is equal to a plus b and c is equal to a into b. And that is a general form of basically factoring a trinomial with a leading coefficient of 1. And that is going to help you a lot wherever you go in mathematics. You are going to need this. So we are basically going to do some problems. Let me check if I haven't made any mistakes. X plus a into x plus b, where b is equal to a plus b and c is equal to a into b. So that is right. So in the next video we're going to do a couple of problems on this, and then we will move on. So I'll see you in the next video.